and digits, use braces and digits to, what do they say to do here? Indicate the set of counting numbers. To indicate the set of counting numbers. Okay. What that just means is this. First of all, what is a brace? My favorite symbol in all of mathematics to make. A brace looks like what? So what? Oh, look, good. This little thing right here. Is that a fun little symbol to make? Those are braces, and those, when you use braces, that shows that you're showing a set of numbers, and a set just means a group of numbers. Okay, now what do I know? What are the counting numbers? We talked about those yesterday. What are the counting numbers? If I asked you to write down all of the counting numbers, how long do you suppose, Peter Pavia, that would take?
Like forever.
Yes, you could never stop because numbers are infinite, they go on forever. So instead of doing that, although counting numbers have a beginning, they have no end. What's the beginning of the counting numbers? Sammy Espanol? Right, you are going to do this. This is how you would show the set of the counting numbers. You would start at 1 and put a few examples down. And then, because they never end, what do we do? The little dot, 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 which is called the what in English? Something like an ellipse, ellipse or something? Ellipsis, is that what it is? An ellipsis. Okay, so this shows the set of counting numbers. If we were showing the set of integers, I could go integers equal. Now how would I show that as a set of numbers in the braces? Think about if you were asked to write integers. What are integers? They are both positive and negative whole numbers. So, do integers have a beginning? No, so the most logical thing to do would be to do the same thing we did here. You start with that 3 dot, whatever we call that, elliptical thing, ellipsis, put a couple examples of like -2, -1, 0, 1, 2, I'm running out of room, and then put the ellipsis at the end of it again. And the beauty of this board is I can move my brace if I can pick it up. Over there. Kind of get the gist of that? This is more definition than just about anything. What about this? If I asked you to show the set of odd numbers. Set of odd numbers. I'll give you a chance to do this one. How would you show me, using the braces, the odd numbers? Give me an example of the odd numbers. I don't think, do we have to go over odd and even numbers? Is everyone pretty much familiar with odd and even numbers? That was the first thing we did in 5th grade. Remember that? It's firmly etched in my mind there. All right, Lutz, you're up. How do I show odd numbers?
You put like 1 and then 3 and then 5 and then 7 and then you do like that.
Okay. Now the question is, what about the odd numbers that are over here?
You do that.
Yeah, you'd have to do the math there. Now you might want to, and this is fine, but you might want to maybe start it with -1 to show that there's a bunch of negatives there. You don't really have to, but you could have done -3, -1, +1. By the way, 0, odd or even?
Neither.
I don't know, I'll have to look and see. 0 when it comes at the end of a number makes it an even number, but 0 by itself? Let me look. You know, there's always those. Yeah, it is even. 0 is even. And another thing to know is every little thing in the set there, okay, each one of these things are called an element of the set. These are all elements. They make up the set. A little seventh grade jargon for you. Those are all elements. Just so you have that written down or know what's on. And then one final thing we're gonna talk about today is, let me stop this because I want it on the number.